Continuing with the 7.4 video for the second part, we were talking about taking the derivative of x raised to a real number c, and we ran out of time. Just want to draw your attention to this far right edge of the screen. If y equals x to the c, we could very quickly take a natural log of both sides, which allows us to bring that power down. Remember, c is just any old real number. Take a derivative. On the left side, we'd get 1 over y, dy dx. On the right side, remember that c is just a constant, and the derivative of the natural log is 1 over x. It follows that dy dx would be c times 1 over x times y. But again, y is actually, as we look at the very top of this proof, x to the c power. And now we can use an exponent property. If we had x to the c all over x to the 1, we could subtract those powers, and we'd wind up with c times x to the c minus 1. That's what our derivative would be. So take a look at example 4. The derivative of x raised up to the radical 5 power is radical 5 times x to the radical 5 minus 1. For part B, we're going to need a chain rule. Drop down radical 7 here, and we'll have 1 plus e to the 3x, but our new exponent is radical 7 minus 1. The derivative of the inside, well, the derivative of e to the 3x is e to the 3x. Chain rule, take the derivative of the inside, you get a 3. Rewriting this, reorganizing, we'll have 3 radical 7 e to the 3x times 1 plus e to the 3x, all raised up to the radical 7 minus 1 power. For part C, e to the e is a constant. A constant to a constant. It's kind of like saying take the derivative of 7 to the 7 or something like that. It's just some arbitrary number. The derivative of that with respect to x is 0. Finally, last problem here. X raised to the x. There's a reason why we've been taking a natural log on both sides so often. It is a wonderful technique to help us take derivatives. When we take a natural log on the left and the right side, I can drop that x down. The derivative on the left would be 1 over y dy dx. However, on the right, we're going to need the product rule. U is equal to x, v is equal to natural log of x, u prime is 1, v prime is 1 over x. I think you can see quickly we'd have x v prime, x times 1 over x, plus 1 times natural log of x. And this leaves us with 1 over y dy dx is equal to a 1 plus the natural log of x. And if we multiplied both sides by y, we'd have y times 1 plus the natural log of x. But again, y is actually x raised to the x power. So we'll have x raised to the x times, in here, 1 plus the natural log of x. And we're done. 2 very quick comments. We'll need this for later. But both of these limits at the very bottom, the limit as h goes to 0 of 1 plus h to the 1 over h power is actually e. And as n goes to infinity of 1 plus over n raised to the n power, that likewise will be an e. We'll talk a lot more about this by the end of this unit. Best of luck to you.